Hey kids, we are doing lesson 24 today, and this one is like a monster of word problems. Okay, now let me rephrase that. It's not that bad, it's only 6 word problems, but they have a lot of work to them, so if I was a 5th grader, I'd probably be super like stressing out, and there's no need to stress out today because I'm going to help you get through these. So lesson 24. Page 267 in your Learn books, and we're going to get through it. In fact, when we're done, you're going to say, that wasn't so bad. Let's start. A vial contains 20 milliliters of medicine. If each dose is 1/8 of the vial, how many milliliters is each dose? Express your answer as a decimal. Well, today we're going to be working with tape diagrams to kind of help you see what is happening. So if the vial contains 20 milliliters and it's in eighths, remember that the denominator can help you see how many pieces your whole should be broken into. Make the whole 20 milliliters, break it into 8 parts. Okay, half, and then half the left, half the right, and then put each section into halves. Okay, now you have eighths, and we're interested in 1/8. So this is the picture. You are trying to find 1/8 of 20. Okay, now it's fraction of a number, which is really, we've done this before so many times. 1 times 20 over 8. Okay, I can simplify this, and I always want to simplify before I multiply. Use 4 as your common factor. Okay, 8 is divisible by 4 2 times, 20 is divisible by 4 5 times, and then I end up with 5 halves, and I have 2 1/2. So it says express your answer as a decimal. So what do I do with 2 1/2? Remember that halves don't equal, I need tenths, hundredths, thousandths. That's what we do in 5th grade. So we're going to take our 2 1/2, and I'm going to leave the 2 alone for a second, and I'm going to multiply by the scale factor. Okay, I'm going to scale it up by 5 so that I can get 5/10. Now I'm going to connect that and have 2 5/10, which is equal to 2 5/10. Huzzah! And so see how easy it was. Like, it might look hard, but when you work it through doing what you know, it's totally possible. So there you go. Express your answer as a decimal. Each dose is 2 5/10 milliliters. Okay, so let's do another one. Change my little thing here. Okay. A container holds 7/10 liters of oil and vinegar. Dressing. 3/4 of the mixture is vinegar. How many liters of vinegar are in the container? Express your answer as both a fraction and a decimal. So we're really trying to check your knowledge today. So if I have a container and it holds 7/10 liter, it's broken into the denominator number of parts. 3/4 is vinegar. Okay, now how many liters of vinegar are in the container? So how many liters of vinegar are in the container? Well, it's 3/4 of 7/10. So today they've got us dealing with whole numbers and fractions, decimals and fractions, and we need to be able to show everything both ways, going back and forth. So change change 7/10 to a fraction, because it's there, it's easy, it's a direct change, and you can straight across multiply 21/40. And so what do I do here? How can I change 21/40 liter? It's a fraction, yay, but what do I do with that? Like, how can I change that to a decimal? I can't use tenths. It's already more than that. 40 doesn't go into 100 because 40 times 2 is 80, and then times 3 is 120. So I will never get to 100 with 40. But you can get to 1,000 by multiplying by a scale factor of 25. And, you know, if we had more time, we could fiddle around on how to get 40 to 1,000, and we could play around with it. Now, there's another way that I want to show you, because sometimes this is going to create a lot of work. We still have a really big multiplication problem here. 5 times 1 is 5. 5 times 2 is 10. Hold that spot. 2 times 1 is 2. 2 times 2 is 4. Got to add, put it all together, and I end up with 525 over 25 times 40, which we know is 1,000. And so this is my decimal here. But don't forget, if you can't come up with this, let's say, I don't know what that is. Remember that every fraction is actually a division problem. It's 21 divided by 40. And this is the old way. This is how we used to do it all the time, so I am not afraid. If you want a decimal value, the top number is divisible by the bottom number. Annex a decimal, put a couple of zeros, and start dividing. So 40 does not go into 21, 0 times. But it does fit into 210. Now I kind of have a clue that I know it's going to be 5, and I always think 4 times 5 would get me 20, so that would be a good place to start. Plus, this is good division review. 5 times 0 is 0, 5 times 4 is 20. Subtract and get 10. Now here's where we got stuck before. 100 isn't divisible by 40 evenly, but I can get it in there 2 times for 80, and that leaves me with 20 left over. Annex one more 0, and then look at what happens. I end up with 24, okay? And so 200 is evenly divisible by 40, and you can get that 5 times. 5 times 0 is 0. 5 times 4 is 20. There it is. And you end up with 0. So here's the decimal, and there's the decimal, and you can get it simply by dividing the numerator by the denominator. And either way, you can end up with a decimal. I always used to do it this way because I would never know that 25/25 was the scale factor. So there you go. Problem solved. Okay, let's do another one. Andres. Andre, not sure. Let's call him Andres. I like that. I like hitting that S. Andres completed a 5-kilometer race in 13 and a half minutes. Notice I said and a half because it's 5/10, which is equal to a half. His sister's time was 1.5 times as long as his time. How long in minutes did it take his sister to run the race? So let's take a look. We've got Andres, and we have his 5-kilometer race in 13.5 minutes. Now his sister, her time was 1.5 times as long as his time. It's all of his, and if we cut his in half, we need another piece that's that half, because hers is 1.5 times as long. Okay, so that's what your tape diagram is helping you to visualize what's happening. How long in minutes did it take his sister to run the race? So what is her time? So what we need to do is we need to do 13.5 times 1.5. Now I already gave you a hint here that the half can be 5/10, so it can be 13.5 times 1.5. Not 0.2. Big confusion there. Kids get confused. It's not 0.2. It's half, which is 5/10 because this is the tenths place. So you have to choose the right number that goes there. 5 out of 10 is half. Now that I have a simple decimal problem, I can set it up in standard algorithm. And remember, you've got options here. If you don't want to put the decimal there, then leave it out and label it as tenths. Okay, but I'm not going to label it as tenths because I already have the decimal there. And you don't need to do it twice. You don't want to have the point and then have the label there too. That's redundant. You don't need that. So multiply with the standard algorithm. 5 times 5 is 25. Then this is 15 plus 2 is 17. 5 times 1 is 5 plus 1 is 6. Hold that spot with a 0. 1 times 5 is 5. 1 times 3 is 3. And then 1. Add 12, 9, 10, and 2. So you should end up with 2025. But where do the decimals go? And I know kids are going, oh, it goes right here. And I'm going, no, it doesn't go right there. This is not addition. This is multiplication. We don't line up the decimal. We count the decimal places. It's really tenths times tenths. Hope I didn't scare anybody there. Okay? Tenths times tenths, that equals hundredths. THS, which means I have to have 2 places to the right. So everybody gets confused when we start doing multi-digit decimal multiplication. But old way, count how many places and have it equal in your answer. Common Core way, label everything in unit form and put the label there and then put it in standard form. You just have lots and lots of different ways. And so anyway, his sister took, if he finished in 13.5, she was 1.5 times as much. So it's like all of the 13. And what's half of 13? Like 6-ish. And so then if you add 6-ish to 13, you get about 20. See, that makes sense. His sister took this many minutes. Ta-da! And there's your win. Okay, next one. I am full of spit and vinegar today. Okay. Let's do another one. A clothing factory uses 1,275 and 2/10 meters of cloth a week to make shirts a week. How much cloth is needed to make 3 3/5 times as many shirts? So if you look at your 1275.2, okay, now this is our meters, and this is in a week. And they're not asking us about time, though. They're just asking us 3 3/5 times as many shirts. So it's about the meters. And we need 1, 2, 3. And the last one, if it was full, 1, 2, 3, 4, 5, we only need this. So we need 3 3/5 times 1275.2. Yep. Okay, so that's a big problem. So we're going to do this times 3 3/5. Now you have options when you get to this point. I want to make this a decimal because then it'll kind of create a simple standard algorithm problem. So what is 3/5 as a decimal? So I'm going to use 2 as my scale factor and get 6/10 and then call it 3.6. And now I have a decimal times a decimal. So let's use the standard algorithm. 1275.2 times 3.6. And again, I'm just going to write the problem as it is. And I'm going to multiply as though the decimals are not there. I'm going to ignore them completely. 2 times 6 is 12. This is 30 plus 1, 31. This is 42. 6 times 7, 42. Plus 3 is 45. 6 times 2 is 12. Plus 4 is 16. And then 6 plus 1 is 7. So your first partial product, 7, 6, 5, 1, 2. Don't put a decimal there. It does not belong there. Okay? Hold the spot with a 0. Move over. 3 times 2, 6. 3 times 5, 15. Carry the 1. 3 times 7 is 21. Plus 1 is 22. Carry the 2. 3 times 2 is 6. Plus 2 is 8. Nothing to carry. 3 times 1 is 3. And there's nothing on top that we're going to add. Second partial product. 3, 8, 2, 5, 6, 0. Add 2. Oops, 2. 6 plus 1 is 7. 5 and 5 is 10. 6, 7, 8, 9. 8 and 7 is 15. And 3 and 1 is 4. Now I have a lot of digits here and I don't have a decimal yet, but you decide, where do you put it? Does it go here? No, it doesn't go right there. It goes tenths times tenths is hundredths. Hope I didn't scare anybody. But there it is. It's 4,590 and 72 hundredths meters of cloth. Okay? Is needed. Okay, so this is where it gets really fun because you're going tenths times tenths is hundredths. Multiplying with decimals is not like adding. Okay? All right. I think of anything else? Nope, not on that one. Okay. 2 more. Look, we're making good time. Okay, there are 3 3/4 as many. Oh man, if I was a 5th grader, I would have never, let me just say it, never, ever have gotten this one. I would have been working on it for like a week and I still wouldn't have gotten the answer and then I'd cry. But since I know how to do it now, I'm not going to cry. 3/4 as many boys as girls in a class of 5th graders. 3/4 as many. If there are 35 students in the class, how many are girls? So I know kids want to just start multiplying and adding and dividing and all that, and I'm going to say, let's make a tape diagram, okay? So 3/4 as many boys as girls. So if I make the girls and the boys, and the blah, and there are 3/4 as many boys. So let's break up this section into all the girls and the boys. Okay, so that you can see this really is non-existent. Okay, I'm just showing you how it would like match in size. 3/4 as many boys as girls. That's what that model looks like. There are a total of 35 students. Okay, and don't feel bad. I would have never ever put this together if it weren't for honestly learning about tape diagrams. So what do you do with this? If you know how many equal sized parts there are, you can split the whole into that many parts. And once you know the size of one, you can know the size of any. So let's take 35 and divide it into 1, 2, 3, 4, 5, 6, 7 pieces. If you were thinking that, you were right on. 5 students in each section. Okay, so what does that mean? Well, it means that each section has 5, and you can just start throwing the 5s down and figure out how many boys, how many girls. And so it asks how many girls, so 5 times 4, you can just look at it, you can add it up if you want. I don't even have to do any calculation, but you would want to write so you can impress your teacher. 5 times 4 equals 20 girls. Okay, there you go. And the last one. Ciro purchased a concert ticket for $56. The cost of the ticket, we're going to have a lot of tape diagrams here. The cost of the ticket was 4/5 the cost of his dinner, and the cost of his hotel was 2.5 times as much as his ticket. So how much did Ciro spend altogether for the concert? Ticket, hotel, and dinner. This sounds like a fun night out. So we do know that the concert ticket is $56. So let's make a tape diagram and call the ticket $56. Okay? Now the cost of the ticket was 4/5 the cost of his dinner. So the dinner, okay, so which one is more? The ticket or the dinner? If the ticket was a fraction of the dinner, then the dinner is more. So we're going to make another tape diagram, and we're going to look at the ticket being 4 parts out of 5 of the dinner. If this is 4, then the dinner would be the 4 plus 1. Okay, now this is 4 out of 5 pieces of the dinner. Okay, Now the cost of the hotel was 2.5 times as much as his ticket. Okay, so again, now I've got the hotel and I've got 2.5 times the ticket. So I'm going to go ahead and make, here's one, and then I'm going to make another one of these with 4 units. That's 2.5. Now that's 2.5. Okay, so now I've got all these pieces. How much did Ciro spend altogether for the concert ticket? Well, I need to look at what I know, which is 56 for the ticket. I can see how many pieces I have here for the ticket, which is going to be 56 divided by 4 parts. Okay, now if you can't do it this way, set it up in long division. 4 goes into 5 one time, multiply, it's always good to review this skill, subtract, bring down, divide, multiply, subtract. Now the size of each piece for each section is going to be 14. And now you can find out the cost of the ticket, the cost of the dinner, the cost of the hotel. You could find 1, you could find 2, you could find 3. And so since we want to know the total for everything, I'm just going to count up all the parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So this is 19 pieces times $14 per piece. And I'm going to start multiplying. 9 times 4, 36. 4 times 1, 4 plus 3 is 7. Hold that spot, 9, 1. Add that 16, and you get 266. And so that is your answer for everything. And I hope you guys become subscribers because I love helping with this math. So subscribe to my fun channel and we will have fun every day doing more math. Usually math, sometimes other stuff too, reading and science every now and then, but mostly math. So I hope it's helpful. I'll see you guys on the next video. Adios.